Good afternoon and welcome at the Badge Team Talk. Thank you all for being here. A lot of people played with this badge, and this awesome badge team will tell you all about it. I hope there will be lots of questions and interaction, but please give it up for the whole badge team, but in this case also for Sebastius.
Cool. Kijk maar. Moet even doorgeven. Heb jij die alvast? Oh. It's my keep out zone. I can't go there and I can't go there. I can only run away. So, hi, welcome to our little presentation called The Adventures of Badge.team, Sunk Cost Fallacy as a Lifestyle. We owe the subtitle to my friend Jurt, who wrote a little piece about the Decennium Badge, where he claimed, for Badge Life people, sunk cost fallacy is not just an option, it's a way of life. Yes, that's very true. So, I'm going to take you through how this little project came into existence. We're going to show you what it did to the event and maybe some plans afterwards. I have two people joining me later on. That's Saka, who did all the puzzles, the main quest design, which you all had fun with, and Benatsky Ralph, who did the software. And I'm leaving out a bunch of people, but that's going to be fine. So, it's going to be fine. No, it's a team effort, and I'll thank everyone in a minute. That's going to be fine. So, we had some design goals, as usual. We always set a set of rules to make this work. We want a name tag. That has to be, a badge has to be a name tag first. You have to be able to write your name or show it on a display, whatever. People need to know who they're talking to, else it wouldn't be a badge. We need to make people connect or interact. I think we succeeded. It should be incredibly easy to get started. No installing tool chains on your laptop, no looking through thick manuals, plug in batteries, go. It should be reusable after the event, and it should be available at the entrance. So this was November, this is our timeline. Okay, yeah, we're just gonna do something basic because we don't have any time. A basic soldering kit, maybe a heart shape with a Hacker Hotel logo on it, and done. Okay. And then Dimitri came, here's some budget, and I want this, and I want... and he was starting to control freak us. We love you, Dimitri. But then, at November 12th, Renzo started the secret Hacker Hotel 2020 design group, which he wasn't invited to. And we went, and we said, hey, we're going to make a badge for you. It's going to be cool. And you can't know anything. That's... It takes a huge amount of trust to trust us with the money of your sponsor, so thank you for that. So, credit where credit is due. This is all Nicolette's fault. So, she said, so I'm obsessed with the fact that the heart shape we use today was first depicted by Egyptians, because crocodile hearts look like that. Okay, we could go full Egyptian theme. Could we really? Should we add puzzles to the badge? Oh, crap. So, the 12th of November was, I think, the most productive day in terms of concept. A lot of stuff was thought up back then. Simon says the theme. Nicolette also did some cool sketches, like our heroes escaping from the evil cat, Egyptian cat goddess Bastet, which I'll talk to you in a bit. Took some convincing for our teammates. I still don't get a strong feeling by the Egyptian stuff, though. It doesn't feel like Valentine. That's the point. In the beginning, it was related. Well, Bastet is the god of love and of cats and of sex and of warfare. It's a very active goddess. So it's totally related to Valentine. So we can pull this off. And Nicolette started scribbling away with our ideas, and we were first thinking like, let's do something like a tablet, and then add some art on top, and then some components in the middle, which also looked very pretty, but it didn't feel like it yet. In the meantime, Ralph started to design a little dev board. So the little processor on your badge, let's see where it is. You can just see it just below the batteries, that little processor, that's this big, huge square you see in the center. flipped upside down, and then he added some little wires in to start prototyping. And before that, we went into looking into Chinese microcontrollers, which are really cheap until you need to get the dev kit to program it. That costs 200 euros, and you can only get them in a few months' time, and you can only use it on Windows. Okay, no. We'll just use something that has an open source toolchain. So we came up with designing a challenge badge, and we came up with designing a mixed reality escape room. 6 challenges. That's why there's the letters hacker on the front on the necklace. So 2 challenges are up front on the badge. There's one you do with each other. That's what some people have called the badge STD or the badge sex. Thank you for that visual cue. Yeah, great. And there were a few hidden inside the badge, so you can get started really easy. Just push a button and stuff will blink, and then you push another button and it will glow angrily with red eyes at you. And then you did it wrong, and you try again, and suddenly you figure out, hey, this is Simon, I can actually do this. And then you figure out, hey, if I switch it off and on, it doesn't reset the random function, so I can just do the same pattern over and over again, and win really easily. So, what did you learn? If you haven't learned it already, you learned some basic decoding. Some people decoded the lanyard, other codes. Some people fixed barcodes. Who would have thought you would have fixed barcodes? It's cool. Connecting USB serial and solving impossible puzzles. So, let's look at some early concepts. So, I don't know if this was a few weeks later, but relatively fast after our original concept, Nicolette came up with this concept art. This was still a sketch. This is not the finished art. This is a sketch. I have no idea how she does it. To the left was the early prototype by Ralph. That's all the parts that are on your badge are there. And to the right is a prototype. There's 3 of them. We're donating one to Jenny's, well, not Jenny's, but to the badge museum she is putting together. She is very adamant about that. It's not her museum. It's for us all. So go visit it at EMF to see the entire collection. Hacker Hotel at the first tryout. I need to take a sip, just a second. So, the prototype boards to test the circuit came in the day we had to order the final production run. So Renze, to his credit, built 3 of them, verified the circuit working, and we went, and away we went. And then 2 days later, oh, there are some short circuits in the circuit because KiCad is stupid. So this whole front, all the bits that are in gold, are conductive. Somehow KiCad isn't aware, at least in the way we worked with it, isn't aware that it's conductive. So we just added some pins and pads and the stuff to the front, and then it all shorted out. Yeah, well, it's what happens. Let's see here. This is where we were. So what's on there? There is some hardware on there. There's an ATtiny 8-bit microcontroller, 10 megahertz, 16 kilobytes of storage, 2 kilobytes of RAM, 265 bytes of EEPROM. We added in a 24C265 32 kilobyte EEPROM. We added a Hall sensor. That's why you had to move around a painting with your badge at the reception area. There's a light sensor, which forced you to put your badge somewhere in your bag to make a challenge work. There's a third sensor that's inside the ATtiny, a temperature sensor. So that's why people were running to the hot air gun and roasting their badge and then running outside to cool it down again. It was like, we need another sensor. Hey, there's a temperature sensor inside. Ooh, what can we do with that? Yeah, that's how it came into existence. There's 30 LEDs of them, which we came to regret a bit later. I'll explain that to you in a bit. 4 buttons, an audio jack, which does both audio and enables badge sex. So it's a multifunction connector. And this time, that one part was not reversed. Yes.
What about the green?
Hmm?
The proper green? Yes.
Oh, the proper green. I'll let Ralph tell you about that during his segment, because he has very strong opinions about LEDs and their colors. So I'll let him. I'll let him finish it up. Yeah, I have some opinions too. I detest the color blue in LEDs, which has been overused for quite some time. So I'm happy to have been in 2 projects which have not a single blue LED. So, in China, the PCBs were made, and then a few days before Chinese New Year, I got an email saying, "Hey, I'm very sorry, but I haven't received the PCBs yet, so I can't put them into the assembly line, and the assembly company won't take any new orders." So yes, we have some bare PCBs in China, 350 of them, and no one to assemble them. So we were already planning to, okay, well, in theory, we could hand pick and place it and put it through a machine. And then Michael Stegen, where are you? There are you, said, "Hey, I've got a pick and place machine." Okay, we did some math. Okay, that should take 20 hours to do. We can in theory assemble it ourselves. So we arranged all that. And then the next morning, and I also called Dimitri and said, "Hey, this is going to be bad." Sorry, but this is going to be bad. And the next morning was, I twisted his arm a bit, and he's the owner of the company is helping out on the production line, and we're going to do your project. Okay, that's going to save us 20 hours of work. No, it didn't. So this is where shit hits the fan. We made several significant boo-boos, which is why we got this nice little reversed logo. Thank you, Dimitri and the what do you call it? And Tim, Get Merch. Thank you for that. We made several. We made a bunch of mistakes. Some were done to us, others were done by us. For one, the little connector on the back is not supposed to be there. We specifically said, hey, we want it loose in the back, so you can solder it on yourself as an extra challenge, because it was supposed to go in the front. Which is, for you, it doesn't really matter, but if you want to use a shitty add-on, which a few friends of us were already planning to make, it doesn't work. Actually, you make reverse polarity, so stuff you put on there will probably burn. So, our good friends, and I forgot to add in the little slide which showed a nice little detail, made an extra board. So they made the beautiful scarab in a nice little kit. They assembled the kits here on in their bungalow. And the tiny little board you see there is the shitty add-on fixer. They have helped us fix shitty add-ons since last year with the helpful Other, and now they're fixing our shitty add-on again, making it slightly less shitty, and adding a beautiful scarab. So, and they gave them away for free. I don't know if there's any left. I'm looking at the people there. All out. Yeah, they made 30 of them and they gave them away for free. That's just pretty awesome. So, thanks for that. And thanks for the little add-on board. Are there any plans to do a second run of the scarab?
Yeah, maybe, why not?
Cool. Who would be interested in getting a scarab? Okay. That'll be 10 euros each, please.
So I guess the answer is yes then.
The answer is yes, people want it. It's beautiful. So, and it looks like this. It's absolutely gorgeous. So that's boo-boo number 1, and it's not so bad, because you could just plug in your USB serial on the back. Okay, you lost the soldering challenge, but whatever. Gonna be fine. Okay, next boo-boo. The lanyard. So we sent in this beautiful little design. And for those who are counting might notice this design is a bit longer than the one you have around your neck. So we got a pre-production photo. Hey, here's your render, and there were some folds in there. We were like, oh, this looks like it's okay, order it. And they chopped off the last 3 segments of the challenge. So the characters now spell out my name instead of the goddess we were supposed to get. What happens? But it's and we fixed it in software. Easy. It's luckily we checked. At least Sake took one home and said, "Oh, I'll check it." And oh crap! But 2 weeks ago, we received all the boxes of badges, and 100% of the badges were not working. Yeah. Oh, yeah. That's worse than we did at SHA, where we had 50% of them not working. And at SHA, it wasn't our fault, and this was, well, it was kind of our fault. We accepted fake parts, so this was definitely our fault. We did something wrong in reading the datasheet. We reversed all the LEDs and other diodes. Yeah. For those who are not really into electronics, if you reverse a diode, it doesn't work. Yeah, okay. It does work nicely as a barrier for electricity, and it does not make light. So, in total, 32 parts were reversed, so that's about 12,000 parts on these little boards that were on the wrong way round. Our fault. China was closed, and then an epidemic hit, so China was closed even more. So we couldn't fix it there. Say like, hey, here you have it back. Try again. No money to do it all over. No time. And this is the thing that's hilarious about us. We're not getting better at the process. We're getting better at thinking up fixes. So we came up with at least 4 different fixes. A friend of us came up with a new logo for us. We have the domain name. You don't have to try it. So the first fix, the minimum viable product, was, okay, we can just swap out the diodes in the power supply. You lose the LEDs, but at least the game can work. But it's meh. 21. Then there is, we could reverse all the LEDs and the diodes. That would take at least 30 minutes. It's the nicest, the purest edition, we like to call it. But it's very hard to do. At least for me, it's hard to do. Renzo says, "Oh no, it's easy. Just put it on a hot plate and then push it around with a little skewer." And yeah, 30 minutes, even with a trained eye, is too long. 30 minutes times 350 badges is impossible. We could replace all the MOSFETs, and we actually prepared for that. There's MOSFETs in the circuitry. I'll show you in a bit. We could swap that out. I even prepared stickers. Okay, pop quiz, little pop quiz. Kapton, at what temperature does it usually supposed to melt? Kapton tape. Melt? Exactly. So I ordered some Kapton sheets to isolate some pads so you could solder on top of it. And then I tried soldering on it, and it melted at less than 200 degrees, where it's supposed to go at 400 degrees. So that was out. Well. So, but it was kind of hard to do, and it was a lot of high-risk steps because you had to cut traces on the board and do other stuff, and it was not ideal. But it was doable, and it was less than half an hour. We think. We haven't actually tried it. So we came up with the final fix, which was removing the MOSFETs entirely, and then adding some wires in, which put the ATtiny out of spec. The ATtiny is specified to draw a certain to source a certain amount of current. We are way out of the specifications. It would lower our brightness. However, on the upside, it's easy to parallelize. Sorry. It's easiest to do. A bunch of the tasks can be done by untrained hand, and we did. So, step 1, we removed 5 times 350 MOSFETs with some pliers, because that's the fastest way to do it. And if you cut carefully, you only damage 1 board out of 350, so that's good. Yeah, I think there were 1 or 2 traces destroyed in this process, so it was excellent. Then there were some diodes in the power supply, which were removed with hot air, and then we put in either the same ones or some new ones. And then we added in some budge wires. We made a nice little map where you have to add in the wires. I'll show you in a bit. Thankfully, a few days before this sweatshop, the radio show Angry Nerds was on, and I was on a phone call with them, and I said, yeah, we're going to do a sweatshop, and it's going to be epic, but the problem is the lack of microscopes and proper soldering stations. We have the hands, but we don't have all the tools. So two of the hosts that were present kindly sponsored a bunch of money to be able to purchase a nice soldering station and this awesome little microscope, which is in the batch hacking area. So thank you, Brenno and Richard, for helping us out in our time of need. And it's slightly blurry, but it shows off the work that we did. You can see one just besides your battery clip on the left. So all those the little groups of free pads with a square around them, that's where MOSFET used to live. And we added in some little barge wires, 5 of them. So in about 10 hours, I think, we soldered in 5 times 350 barge wires. So that's 1750 wires. It's a lot of them. But they were working, all of them, except I think we broke 2 or 3 of them. So that's why you have margins for error. Not because China is bad at producing them, but because we always mess up. Yeah, you have to be fair about that. The breakage from our production in China is usually between 1 and 2%. And we upped that to about 5%. So another sweatshop happened to make all the bags and to program and another night to program all the software in. It's a lot of stuff to do, especially if you have to fix them first. In the matter of eating your own dog food, we used SHA badges to program the code into your badges, because we still have a bunch of them. And it's easier to do this than set up a laptop and install some software and some dependencies, and then you have to do this Python scripts, which installs another 20 Python scripts, which install another 20 Python scripts, or you could just use a SHA badge. So what's coming soon for this for the SHA badge? We already have the EEPROM programmer in the hatchery, so you can just do that yourself if you want to. What's coming soon-ish? I'm looking at Jan. He's saying, it's going to be soon-ish. Soon you'll be able to, the code will be released today because we wanted to keep it a little bit secret from you. Soon there will be a compiler and a programmer software in the hatchery, so you can just write code for this badge in the hatchery, use a SHA badge to put it on, so you don't need to install toolchains on your laptop, that sort of stuff. We hope you will use these tools to make a master quest with this badge for next year. Just a little challenge for you people. Make a quest for us. That would be cool. So I'm going to switch it over to Sake, who is going to tell you about the quest. Now, be out of your way. And say the mine effort? Yeah.
Okay. First of all, who solved all the challenges? Show your proud design. Throw your badges. Woo! Nice. Well done. Actually, the first 2 people, the first 3 people that solved it was on Friday night. They were working on it like for 12 hours straight, and big applause for these people because it's really, really amazing. For me, this whole frenzy started with a little tweet or a little Telegram message from Renzo, like, hey, we're gonna do a simple microprocessor and we might want to do a game. Are you interested? Well, okay, I'm interested. And then my life went down the drains. Because it started with a little processor, and we took a little bigger processor, and the ideas for the game were extended. And, well, I'm me, so I get carried away. And so I was thinking, I need a game that is, it needs to be simple, because it's only 16K of RAM. We need to address all the hardware, so there's not much room to really design a game. So I was really bugging my mind of how am I going to do this, and I ended up designing a JSON file format in which everything that you find in a game is just the same type of object, and it has some attributes. So what are the basic ones? You have, of course, a description. You have a name. That's what you see if you look at objects. There's an action mask on what you can do with this object. Can you talk to it? Can you use it? Can you look at it from the other object? Stuff like that. Then there's ACL, so control access control is. So when can you look at this object? When can you see it? Will it be visible or not? And that has messages like if you were trying to look at it and it doesn't, you're not allowed to. You get a message, and then I thought, oh, we need LED effects and sound effects. So I added the effects type as well. And basically, this is what controls the whole game. So this is one object. It's the room 101, in which you who turned on the television. Did you try to turn it off again? It really is room 101. One of the fun parts in this is that you can set a state, because the whole game is controlled by state. There's 127 state bits, of which in the end I only use like 20 or so. But based on these state bits, some things happen or don't happen. And you can actually set a state and use it in the same object again to toggle what you can do. So you can use the minibar once, but you can't use it twice. You get a different message. So that's all been done in this JSON format. And that's what that's my request to you. Like, I'm going to describe this JSON format for you. I'm going to give you the tools to compile this JSON format into the Flash format. And then if we put it somewhere that people can download it, flash it with their other badge, then you have a new game in the badge. So we're open sourcing the game format, and I hope somebody finds the time and the interest to develop new games for this. So when you compile the game, I had a 32K ROM to my proposal, or to my available. And people said, 32K, what are you doing? Are you writing a book? I said, no, I need to write a game. It needs some room. Okay. So I didn't know how much room I would need in the end. But in the end, it turned out to be 20K. That the whole game is 20K of data. So there's 61 objects in the game, and yeah, it's a lot of fun. I didn't expect people to be working on it this long, but that's because I always underestimate the time needed to solve my puzzles. I do other puzzles as well. So yeah, for me it was a real nice journey to be introduced to the Batch team and do something useful for the Batch team. I was on their Telegram list for a while, since Hack Hotel last year. And I wanted to be involved, but like I can't do a hardware design, I can't do firmware design, I can't do anything. Well, I can make a game. So this morning I found my cheat sheet. I have a T-shirt, a Wireshark keyboard shortcut cheat sheet. It's on the sticker table, and I found it on the table. I said, "Oh, really nice." People look at it, and then I noticed it was used as a just as a piece of paper to solve the puzzle from the bed. So that's where my two worlds collide, in this little piece of paper. Who was it that used this? Well, not it. Good, thank you. All right, that's my part. So I hope you enjoyed the game.
Staat gewoon op mijn scherm. Gewoon pijltje naar rechts en dan.
Okay, now about the software. Let's see how this works. Yeah, okay. Yeah, I was invited to help out the Batch team by, I don't know, I don't remember anymore, but I thought, yeah, I have a few spare hours. Yeah, I can help them out. Yeah, well, no, that was a mistake. And so, well, it turned out to be, I think, more than 200 hours, but oh well, it's done, and it worked, and people were enjoying it, so I'm glad I did it. About the microcontroller, I don't know if you can read any of it, but I'll tell you anyway. The ATtiny is a controller, one of the newer ones in the AVR series, and it has a nice set of features that some other AVR controllers don't have, like Arduino and other previous versions. Well, already mentioned, we had 16Ks of flash, some EEPROM, some SRAM, not much, but good enough. There's a 20 megahertz clock, which we divided in two to get the 10 megahertz we needed. Some ultra-low power clock that's used for timing, yeah, other things in the games. The program interface is a single-pin interface, so you can just program, debug, and yeah, do it with a single wire. And to make things easy for you, we added a little resistor so you don't have to edit if you want to reprogram it with serial converter. You can just use a simple USB serial converter to program the batch. Well, that will be explained on the batch team website, I think. Yeah, okay. There's a lot of timers inside the chip. We used a lot of them. There is a single, or is it double? I know, there's one of the 16-bit timers that can be split in two. So you have 6 PWM channels for the LEDs to set the brightness, and they are synced together. So you can, yeah, just with a little piece of code, you can control all of the LEDs without user intervention. It's all interrupt-based, and we used yeah, about 10 interrupts for the whole batch to get everything running. Yeah, we had a serial UART inside of it, 2-wire interface. Yeah, that was a bit troublesome for me because I forgot that's a 7-bit address of the chip, and you have to shift it one left, and then you can get some data out of the chip. So last night, I think I wasted 5 hours just to find out that I had to shift the address of the chip to make it talk back to the ATtiny, and well, 5 hours left. But still, in the end, it worked, and I was really glad I could fix it in time because we really needed some more lines of code because we were running out of flash space, about 10 times or so. Yeah. Yeah. In the end, we have 2 bytes left. That's 1 instruction word. Yeah. Yeah, it just fits. Yeah. Okay. Yeah. Another thing on this ATtiny is there's a digital to analog converter. It is only 8 bits, but it's enough for audio and stuff. You don't have to use timers to make a PWM wave and filter it and stuff like that to get an analog voltage. And it's easy to use, and we have used it for the audio and for the batch communications. So that was a really nice feature of this chip. The internal temperature sensor is also used in one of the challenges of the badges. Well, that's all cool. But the datasheet, previous datasheets made by Atmel were, well, they were fine, they were nice to read. Structure was good. But Microchip bought AVR of Atmel, and they made this datasheet, but it's not really readable, at least for me. No addressing mentioned anywhere, I think. Lots of errors, and well, okay. I managed to get working code out of it, but well, it was a pain in the ass, but oh well, next time better. Okay, the examples were also unreadable, at least to me. They had this Atmel Studio thing, and they have some examples. And yeah, what I want you to write I2C interrupt routine. It should be just a few lines of code. But now they split it up in about 20 functions or something like that. In, I think, 10 libraries split. So it was unreadable to me, so, well, in the end, I wrote it myself. Yeah, yeah. And the software is also, yeah, it's only usable on Windows 10, the AVR Studio. And you can only install it when the temperature is right and the moon is, well, yeah, something like that. Yeah. Okay, now about code. We had, this is the main loop. Well, parts of it. Couldn't fit it on the screen, right? What it does is do some setup, some testing, game state loading, and after that there's a loop. And you see there, if generate audio, that's a thing that does the audio. The audio, if there's playing audio, it will consume the most time of the processor because we needed to play samples, load it into memory, and make some noise and stuff like that. No, okay, audio is taking up the most part. Then we have the games. First, we have some LED blinking and victory dance. If you complete the badge, you get a nice blinky thing going on. Text adventure, magnet maze, lanyard code, best that dictates. It's all called from within the main loop. They only get a very small amount of time each, and then, well... Okay, I'll hurry up. Okay, so it all runs, and yeah, it doesn't take too much time don't have much time to return to the main routine, so audio would else be very glitchy. Okay, a bit things about text venture. We had some cheat codes. I think nobody found out cheat codes, right? Did anyone find out cheat codes? Did anyone try to read out the external EPROM and decode it?
I tried both of those and nothing happened.
What?
What went wrong? IDDQD.
IDDQD, yeah. Oh, you tried? Really?
It didn't work.
Oh, okay. Oh well. Yeah. Okay, should work. Maybe, yeah, has to be lowercase in this thing, I think. Yeah, sorry. Yeah. All right. Yep. Well, there's some hidden cheat codes. There are actual cheat codes. Oh, the hidden cheat code, if you find it, it resets the game state, so you have to start all over again. Oh, I'm sorry for that. Yeah. Yeah. And the priest talks in hexadecimal because we needed some more room for the code, so no divisions or modulo, except for the powers of 2. Yeah, only that. So hex it is. Okay. Some file for resources for doing stuff. Decryption. Well, it was decrypted, encrypted, but well, you should have been able to solve it. Generate audio. Well, you have to find out that yourself. You don't have time to do that, but it's just some. There's not really samples on there. It's all generated audio, real time. Yeah. Okay. Long times, no sleep. Well, for me at least sometimes, and for other people as well in the team. Yeah. Now debugging. I2C. I think I mentioned already. There's some errors in the datasheet. Optimizing code was taking a long time, but at least there were good people helping us and helping me, and yeah, it all went wrong. It went well in the end, and we had an awesome badge. So thank you. Yeah.
Okay. So I need to speed up, I think. Let's look a little bit at the event. There were a lot of people on a quest, which was fun. So the first day, technically the second day, the challenge was solved. But even today, I saw these people doing the little maze, hidden in plain sight. When I came into the hotel, I didn't even see it hanging, even though I made the damn thing. Well, I made the printout. The puzzle was, and the magnets and everything was Sakus. So. Without further ado, there were some winners to our little challenge. They stayed up until I think 5 a.m. I think they went 4:30 a.m. They were hacking that badge until I think they spent about 14 hours at least each. So Myrtle, Adot, and Tempestas, where are you? Okay, shall we have them up front, Dimitri? Yes. Shall we do that now? Yes. I'll give you this.
So yeah, here they are, the winners of this crazy contest. They worked through the night. We were drinking outside, lots of alcohol, and then suddenly someone stormed out. And at first it was Myrtle, followed by the other guys. And Myrtle was really the first one to came out of the restaurant, and I was like, yeah, I solved it. So that was really cool. And then deciding on the prize, when before Hacker Hotel, Renze said to me, this is a really hard challenge. If people would know how to solve this, they really deserve something. So basically I had one ticket for the one who solved it. Now it's free, so we leave it up to them how to divide it up to them, but they won one free ticket for a one-person room. So it's the equivalent worth of like this year's edition, 250 euros. So please give it up for the winners
Yeah.
of this badge challenge.
And as a nice little commemoration, our friends had some little scarabs left over, so you can add those to your badge. So give them another round of applause, because I really need to speed up. Well done.
Congratulations and see you next year.
Cool.
Maybe you guys, as you are so smart, can make us the new challenge.
Yes, I hope so. So, oh, by the way, there is one more badge. This weekend is Disobey in Finland. Renze somehow manages to help out with 2 badges in one go. He's holding one there. So Disobey, the Finland team, started out with our firmware, added on a lot of stuff. They have a push-to-talk walkie-talkie over Wi-Fi, I think. They run the same code base, they run the same hatchery. I think they made several thousand units. So the badge team firmware is now at least on 12,000 badges, as far as I can tell. Which is ridiculous. And now we're on the subject of numbers. Let's give you some more. We made 350 badges. We had 300 for the event. We reserved 10 for a specific sponsor whose condition to sponsor was, hey, I want to buy 10 badges in addition to our sponsor amount. So thank you for that. We had 40 badges for breakage and promo, so that's about 10%, which we usually do, 10 or 20%. We had 10,500 LEDs on there, which is insane considering it's 350 badges. We had 16 kilograms of AA batteries. We had 2 smoking capacitors. Very sorry about that. Somehow with mounting the battery boxes, we reversed a few and poof. And it's our tantalum capacitors, and tantalum is electrical engineers' terminology for highly flammable. Just so you know. There were, as far as we could tell, 0 cheaters or hacks. Lame. Come on. Where are all those chip whisperers, voltage glitching, whatever you do? Nobody decrypted the EEPROM. Come on. So I expect you to do your homework this weekend. Or next weekend. Come on, hack this thing. Let's see if you can figure it all out without you looking at the firmware. So, cost breakdown is up next. We spent about €11.30 per badge, roughly 4,000 euros in total, of which the PCB, just the bare board, was one of the more significant one, and the components. We had a huge discount on PCB assembly, about $500 worth of discount, so that saved a lot. Sorry?
Because of the design.
Yeah, because he liked us. We bought some USB cereals, some bags. We had a sponsor this year for our drinks and pizza during the sweatshops, so thank you for that. It really helps out to keep volunteers hydrated and fed and happy, so they can do more work for us, so thank you for that. We spent 6% of the budget on customs. We spent 4% of the budget on batteries. Batteries are stupidly expensive. So we had some sponsors to make this all happen, so I'm going to name them all. And I'm probably mispronouncing all of them. So Magion, Stegen Electronics, Access 42. I can look here. Why am I looking there? Aureo ICT and Allnet China. Allnet China is also the producer, the person who arranged having this produced. So give them a round of applause, please. So before Dimitri kills me, I would like to do just a little sneak preview about what is next. And we're very sorry, we have no time for making a badge for Hacker Hotel 21. But feel free to volunteer, make a little challenge for this, do a little design, whatever. We can support you, we can help you out, we can gives you some input, we can put you in touch with the right people. But it's up to someone else to make the Hacker Hotel badge, because for us, it's MCH 2021, also known as Might Cause Hair Pulling. Yes, it may contain hackers. And we came up with a theme, which I think you'll like, because any sufficiently advanced technology is indistinguishable from magic. And magic is where we're going to go next with our badge. So we set some design goals already, and then I'm really going to close off. Design goals for Merlin's Cyber Heirloom is, on the technical side, we want to make FPGAs truly accessible. Not with this toolchain bullshit. Just... You cost me hours with your workshop, Paul. But the tool chains need to go if you want to play with these things at a camp. On the financial side, we have some goals. We want to make at least 4K units working, so we need to make 4.5 or 5K units. We have a budget of 75,000 euros. That comes down to, if you subtract the VAT and other stuff, roughly 12 euros and 40 cents per badge we can spend. So it's going to be another challenge to get it all done. It should be for the visitor, the user story, the thing that's actually most important to get people on your badge. This was one of the first we actually did a proper user story, and it worked out. It needs to be a name tag, again. It needs to be super easy to get started. People need to learn something. Well, should be enabled to learn something. You don't need to do anything. It's a holiday. We would like you to embark with others on a quest. More on that in the next months. And we really need to augment the event. So, timeline, what are we looking at? So this March till August, we're doing proof of concept stuff. Just experimenting with dev kits, tinkering stuff together, get our art and our theme proper, our user story correct. Finding some component sponsors, because FPGAs are not cheap. Out of this budget, we cannot do FPGAs. So we need to find some sponsors for that. And then in September, we should be able to do a prototype. In November, we should have the final design with the art. And then in January, we have final design, final 2 dot, whatever. And then in February, we can do a test run of final design, final, really, final. And then March, we should be able to go into production, have the Gold Master firmware. And then in June and July, we should be able to do our sweatshops and do all the rework that needs to be done, because we screwed up again. And then in August is MCH 2021, so please see us there. So, thanks to our badge team. Guru, Sake, Benatsky, Noor, Neko, Anjan, Tom and Renze. Thank you all for this. I didn't put it up.
No, and I completely agreed with this. Only says Anne, yeah, as long as there's no dash in there, I don't care.
As long as there's no dash in there, it's all good. So, we have some honorary badge team members. Michael Stegen, who has been with us since the beginning, helping out at sweatshops while also sponsoring. Thank you for that. Rob Elboro, our sponsor for the sweatshops, helping out during sweatshops and sponsoring drinks and food. Yillis, where are you? Not here. He's doing his own workshop. Awesome person. Find him, do his workshop. He's great. And OP Raptor, also with us since Hacker Hotel last year, I think. Thank you for all your shitty add-ons and help and everything. So, we would like, if you're interested in joining us on our quest to make nice quests for MCH21, we would like you to join us. We have a Telegram group. Sorry about that, but that's the easiest way to communicate for us right now. And you can join us and have a chat with us. And then if you're really enthusiastic, you can join the secret design group, which is never really a secret. We'll tweet about it anyway. But you can join us. We would like you to join us, because the team is okay, but we would like some more people with varied skills. We don't need just electronic designers. We don't need just programmers. We have someone working on the storyline, someone working on quests, someone working on photography during our sweatshops. Everyone can help out, and it's fun to be part of this team. So that's it, as far as I can tell. So if you have any questions, please let me hear them. Oh, is there not one of those rubber things we can throw around at people, their faces? No? Oh. I haven't been to any talks, sorry.
There's no time. The next talk is already here. So.
The next talk is already here?
Yes.
Oh.
Green lads.
Green lads. Find Benatsky later.
But. Hello.
Okay.
Just before the other talk starts, I would like to have the badge team on stage, and I would like to ask our house photographer, maybe someone can wake him up in the corner over there. I would like to ask him to make a picture of the whole badge team in front of the Hacker Hotel banner, because they did an awesome job. So give it up for them again, because they had sleepless nights.